as promised, we're going to talk in more detail about application performance monitoring. I'm still Joe Rustad. So we're just going to skip this because we did that earlier. I think everyone was here earlier. This is application performance management is a discipline that ensures availability and performance of an application to deliver its business value. So that's the system. Jeff said it earlier, management is the system, monitoring is the function. So there's more details there. Again, the idea is that you're ensuring that the application can do what it's supposed to. So if you've got a student registration website, is it working? Are students getting registered? How do you make sure that happens? So here's what we're going to cover today. What is an application? And we're going to talk about how we do APM and why we do it. And we'll talk about solving problems with applications. So an application is the intersection of transactions and infrastructure. That's how I define an application, and that means that you have to understand what a transaction is. A transaction is the action taken by an application. So a transaction is when you log onto a website. When you log in and it finds your user and validates your password, that's a transaction from this perspective. When you download a song, clicking on the link, downloading the song, that's a transaction. We're Dell, so you might go to our website and build and purchase a new laptop. All of that could be considered doing the whole step, building, selecting the right size and applying the coupon code and getting the laptop shipped could be considered a transaction. And then some of the things that Jeff talked about last time, specific domains have smaller transactions, an individual web page request, the SQL statement. So you might have in a particular page, you might run 100 SQL statements. To the database, one of those SQL statements is considered a transaction. So first question, see if you're paying attention. Can anyone think of other kinds of transactions that we would measure as actions taken by an application? Raise your hand if you want to, or just shout it out. Yes? Say? Okay. Oh, log out. Log out, yes, absolutely. There you go. All right. Yeah. That one. Yeah. All right. Anyone else has an example of a transaction after? Okay. Anyone else? So we have log out. So that anything you would do on a website, like what would you do? We would go and, yep.
You sign up for a website.
Sign up for the website, yes. So there you go. All right. What is infrastructure? It's the physical and logical components of your application. So all the stuff Jeff talked about, physical, virtual, cloud, a virtual machine, a router, the server that runs the virtual system is called an ESX server if it's in VMware. SAN, that's your storage array. And then the application infrastructure is the software components. So operating system, a database, anything like that. So software system, software components, your application server. And both of those types of things, the hardware and software infrastructure, we call it the runtime architecture. So that's what that is. So just to kind of illustrate this point, this is an application running. We've got a web page, and it's sending HTTP requests to the web server, or the app server, and then the app server is sending SQL to the database. So the app server and database are considered infrastructure elements. That's part of the infrastructure. And the SQL and the HTTP calls, those are transactional elements. They don't actually exist. They're not entities. They are transactions. They are the flow of the river. And the physical infrastructure is the shore and so the transactions are things that happen to your application, for lack of a better term. But that was a very simple infrastructure view. This is more like what happens in a real view. If you look at this diagram, the colors might be like the green application would be together, and the blue application would be a different application. And what you have are multiple servers, multiple hypervisors, ESX servers, and they're running virtual machines. Those aren't real systems; they're virtual machines, and they're connected by routers and load balancers and a SAN array. The SAN is a storage network, and that is partitioned logically into different areas called LUNs that are mapped to the different applications. That's more like a real infrastructure, and that's a fairly simplified view. So now this is where this gets interesting. Transactions cost something. If you serve a web page from your application, it uses a little bit of CPU. It uses a little bit of network bandwidth. It uses disk I/O. Those things are limited resources. Remember, when we talked about metrics, we talked about performance and throughput. That would be how fast are the transactions, how many transactions are there. Whereas resource and availability metrics are about the cost of these things. So if we add this up, we see that we get CPU and memory pressure from the CPU that's used. It's a shared resource. There's only so much CPU to go around. We get network throughput from the usage of the network. So that's gonna be a bottleneck if you have too much network requests going on. And you get I/O throughput in your SAN. That's the most expensive kind of resource that there is right now. So all these things together, they add up. So when you look at it, I got green CPU usage, red CPU usage, blue CPU usage, and when they add up, that goes over the amount. If they add up at the same time, then they all use the shared resource, and it gets too high, and you end up waiting. So you can't just monitor the one application by itself. You have to know how it's impacting the whole infrastructure and how the infrastructure is impacting it. Is that clear? Do we have any questions about that? It's a shared resource, and that's really important in understanding a real runtime system. So just to remember, CPU pressure comes from that CPU, but any other kind of shared resource in these virtual environments, things are shared. Everything is shared, and you don't just buy the biggest router you can buy. You buy the router you need. So the network throughput, you try and size it right, which means that if everybody spikes at the same time, it's going to get taxed. The whole point of virtualization is that you don't buy enough CPU to run all of the systems at full capacity all the time. You buy just enough to run normally, so you're going to get resource contention. There's another kind of resource competition for logical resources. And these are things like thread pools. How many threads am I running? If your application asks for more, it's got a limit. There's a limit to these are usually like sizes of arrays in some system setting. Like there might be a number of file handles open, or this one is connection pools. Pools, it's usually called a pool or so this one's a challenge. So if anyone can come up with an example, I'll be impressed. So any other kinds of logical resources that you can think of. It's not a physical resource, but it's limited. Your application has to use these, but it's limited. Yeah.
Logs.
Locks, yes, absolutely. Locks, good answer. So, what do we do to monitor these? We monitor transactions for response time. We monitor infrastructure for resource utilization, and we correlate the two. That's the trick. This is a picture of a system of an application architecture with the monitoring in place. So you see up here, this is the same picture that Jeff drew earlier. Web servers, application servers, database servers. So what we do is on the web servers and application servers, we put an agent. Put an agent on it. And that collects the metrics to show us the resource utilization. And then to get the response time, this is one of the methods we can have an appliance that's hooked up to the network device that can watch what the users are doing. And we put agents on the database that monitor the database. This is everything Jeff talked about, so hopefully it's coming together. We put an agent, we install extra software on the different pieces in the infrastructure, and then that feeds back to our management server. And then you use the management server with your user interface. So here are your users. Users are using this side. They're coming into the network. You're monitoring all the pieces. And we put the pieces together to build the metrics, build the models, and do the monitoring. All right. So back to this. This is the key thing about APM. You're ensuring the availability and performance of an application so that it can deliver the business value. These are the definitions. Availability is the application running. If it's not running, it can't deliver any business value. And then, is it performing well? If you go to log into a website and it's slow, you might leave. That's bad. That's almost as bad as it not working. And the business value, are people able to do the really important things that they need to do? It might mean completely different things for different companies or different people. So back to the persona, the administrator of the university might think that it's okay if it takes 10 seconds to register for a course, as long as everyone who tried to register was fairly accepted. But if I'm selling a laptop and it takes 10 seconds for you to go to the laptop detail page, that's probably too long, because you might decide to go buy a different laptop. So again, these tools are part of a system. So they're part of a process. You have to respond to alerts. It has to make the alerts, and you get them, and you have to do something. It has to help you troubleshoot. This is new, that we haven't covered this yet. It has to help you triage and investigate the problem. So we have to not just provide data to tell you it's wrong. Now with APM, it's really important to provide data that helps you understand the nature of the problem. And you have to fix it. Then you can also do projection, capacity planning tuning, preemptive troubleshooting, things in advance before the problem happens. Predict that there's going to be a problem. Those are very valuable to people who are trying to run their website. Has anyone heard of Gartner? Raise your hand if you've heard of Gartner and you're not named Yinghua. Gartner. Gartner is a very important analyst in the APM business and in fact all of IT. And so they made a definition of APM. And it's, I'll just, again, there's 5 elements. End user monitoring, runtime architecture, transaction profiling, deep dive monitoring. Those are the areas. So I lay it out like this. Start with end user, then you go to the runtime architecture, do your transactional analysis to diagnose the problem, then you go into deep dive to find out more about the actual component that's got a problem. And then over all of it, you've got analytics. So we'll just get it translated for you in case it's not clear. The analytics are they run through the whole process to make it easier for the user. Talk about end user monitoring. So end user monitoring, you want availability and performance, both those categories, and you want to be alerted when end users can't access the application or they can't get the value out of it. So you have to understand the impact of the problem. If you get an alert, you have to analyze it and say, how bad is this problem? So those are the key questions that you would ask. You also want to use it when there aren't problems to understand your customer behavior, and you need to, when you have errors, you need to understand the context of them. So here's the way you do it, and I made Jeff skip over this so we could spend some more time on this. Synthetic transactions are it's a way that we record going to a website. So you say, here's how you log into this application. Here's how you place an order. Usually when you're using synthetic transactions to place an order, you'll have a special magic code in your application so you can place an order. So if you're going to book a train ticket, if you're running a train booking site, you would have a fake way to do it. So you don't actually sell the seat to yourself, because then your synthetic transaction would be buying a lot of train tickets. So that is really interesting, because it's the only way that you can tell that your site is totally inaccessible is to run synthetic monitoring from outside your system. Any other kind of monitoring, you can only tell that there is no one using it. With synthetics, you can tell that it can't be used. The other 2 ways that we do end user monitoring, and they're real end user monitoring. Synthetic is like a fake user. Real end user monitoring, we use browser instrumentation. So modern browsers have APIs to collect performance details. What hits were caused by this website, going to this website, how many resources were downloaded, how much time did it take. So you can put JavaScript into the page of the website that just collects that information and sends it back to the monitoring system. And then packet sniffing, and that's what I showed in the architecture diagram earlier. Packet sniffing is a way you can put a sniffer, if you ever use TCP dump or Wireshark on your system. We have a really big version of that will watch all the packets coming in and out of a website, and it can be huge, like a major website. And we record the packets, and then we use that packet detail to interpret the response time and behavior of the users. So here's how you use it. So almost all this data is coming from the end user monitoring solution. So we have a summary of the performance. I showed this example earlier, actually. We have a breakdown of how many transactions were good, and then we can show around the world, and according to other dimensions, what is the impact of problems. So in this case, Canada and China are having really bad performance. United States and Russia are having just pretty bad performance. Everyone else is okay. We also see that we break it down by device type, by a number of other factors, so that you can see if a problem is related to everybody or just one thing. So the idea with this end user monitoring is, am I having a problem, and how widespread is the problem? You can do trending. You can collect metrics. So in this case, this is the metric for performance violations in this location in Toronto. Or this is performance violations overall. So Toronto happens to have the most in this case. And we see it over time. So you can understand performance problems. Are they coming from one place or everywhere? Location is really important in user monitoring because you're dealing with the internet. And the internet is inherently faulty. So if you have problems on your website, people aren't accessing the site, it could be their connection, it could be their router at home, and you need to eliminate that. So you need to look for geographic trends to see if it's a problem with your infrastructure or the internet. And then what's interesting about this is in Foglight, you can then retrieve the actual visualization of the page that they went to. So if you're using the packet sniffing, you can recreate the entire web page. This is recorded from an end user that went to this website and did this action and typed in that number and hit save. This is an example of a phone number that's the wrong format, and they typed it in and it had an error. So if you had an error, you go and look at what did they type into the page, and then you can understand that, oh, well, it's an error in handling that kind of phone number. Got a few examples here just of the impact that we did for mockups. The idea is that each one of these shows a different kind of problem, has a different kind of impact. So in this case, the bars represent the number of users, and the color represents if they had good, fair, poor performance or had an error. And in this case, we started having errors near the end, and then people stopped coming. So that's pretty serious. You're looking for a trend like that. And you can see that it's all in the United States that we're having errors. In this case, it's very similar, except that its poor performance is causing people not to show up. And you can see it's affecting all device types, all browsers. It's not specific, and it's everywhere in the world. So something happened to your infrastructure. It's slow. This is a really bad problem for performance. Yes? Oh, that's a really good question.
Do you pay all the numbers, credit cards,
so
numbers on the website? So it does sometimes may cause a lot of problems.
So yeah, that's a really good question. I'll talk about that. This is an example from our test lab. So we didn't turn on the filtering. The system does have filtering. The privacy concerns. This monitoring is based on. This is a really good question, so I'll address it. The monitoring is internal, so the application owner already knows this information. The user entered it, but there is a standards a standards board called PCI, which talks about how you're supposed to hide data from the administrators of the application. So Foglight does that. So if you were building this yourself, you would have to adhere to those same standards. So in this example, the fields are left open, but in a real deployment, we automatically filter, and then you can set up additional filters to hide fields from this view. Yes?
Does all the customers know they have other people could see them?
Well, when you use a website, the owner of the website administrator could see whatever they're serving you.
So everything we type on the website can be seen by the administrators from this kind of administrations.
Well, again, we filter it, but it's when you submit. It's not everything you type. It doesn't track things that you don't submit. So if you just type it and change your mind, it doesn't record it. So, but it's, again, for private data, it's fine. It's a great question. For private data, it gets filtered for the user of Foglight. That's really a really good observation. Actually, I don't want to skip ahead. Any other questions about that? So this particular example is what happens when the internet on one city goes out. So just a small proportion of the users start seeing poor performance, and you can see the locations impacted is just Canada. So we had poor performance, but really there's a the performance is localized. So in this case, this is a problem you really can't do anything about except maybe call your CDN. And this problem is you got a spike in traffic, and now you have a bunch of new errors. So new people are coming in, and you have a bunch of new errors. And if you look at everything outside of the United States, in this case, the processing doesn't work in an international part of the app that never got tested, and some ads went up on international websites. Everybody came to try your new thing, but it just doesn't work. So that we use end user monitoring to gather the data to show you these different impacts in all these different dimensions, so that you can interpret what's the scope of the problem, and is it something in my infrastructure or outside. Oh, I got a blank screen there. So the next step is runtime architecture. So runtime architecture is about visualizing the system to understand if a problem is everywhere or just in one place. And remember the views we've been looking at. Oops, I don't have an example. The views we were looking at before, they can get really complicated really fast. You have virtualization, storage. It's very complicated. So visualizing the runtime architecture isn't just throwing up a list of systems. A lot of administrators have thousands of systems that they have to look at, and they don't know where their application is running. There's a system called vMotion that runs in hypervisors. Well, they'll move your application from one system to another, and that is why you need to have these tools automated and showing you the runtime architecture as you go. So this is an example from an older version of Foglight that shows kind of the runtime architecture with the state of alarms. So there's a little icon there, and it says there's problems in the application server tier. And but you can then switch that view based on the topology and the relationships, and group it by virtual infrastructure. So what ESX servers is that running on? Having that flexibility to visualize your runtime environment in a way that is simple when you need it, but flexible if there's a problem that you have to dig into is really important. So in this case, we're looking at this is the runtime architecture of that same application we saw, but grouped by the hypervisor that it's running on. And then we've got a view of the hypervisor, and we're seeing where the competition is coming from. So we're viewing the competition and and the structure at the same time. But if you tried to view the entire picture of the whole runtime architecture of all the applications running on this virtualization server, all the details would get lost. It's too much data for you to look at. This is just a small example of a storage architecture. So this is something you visualize. Again, it looks complicated, but this is a tiny piece of it. The storage architectures are massive. So it's made up of physical and logical components. I know in the back it probably looks completely indecipherable. So any questions on runtime architecture? Any of these? It's a picture of the system, and it's got to look as close to understandable as possible. Transactional analysis. So transactional analysis is about getting a hold of those transactions that we saw, the HTTP requests, those turn into method calls, those turn into SQL calls, understanding how that works. Which transactions are spending the most time and where are they spending their time? And to do that, you have to follow the transactions across boundaries. So how do you do it? Jeff talked about this a little bit earlier, but you have to insert instrumentation into the app server so that it can watch the code and measure it. It measures which function calls took the most time. This is a really interesting technology because you add it to an existing application. If I asked you in an application that you wrote to tell me where the time was spent, you'd use a profiler. If I told you had to tell me where the time was spent all the time while it's running in production, you might add some statements, some log messages in there. Well, this function took 10 seconds and this function took 1 second. But if you did that, it would be a huge maintenance nightmare. So you have a tool which is essentially a production profiler that does that. And then if I said now you have to track that information across when your application calls another application, you have to tell me that application took the time and not your application. Now that's getting as complex for you as actually doing the application development. So you need a tool, and that's what this does. So here's an example. You've got the service request or the web page request, any kind of request that comes in, and it calls components in this app server. This app server makes a call to this one, and so we have to follow the transaction through the different methods inside of each app server, and then we have to recreate it to get that transaction profile. So, and actually it's tricky because there's more than one type of communication that app servers can make to each other. They can make a HTTP call, they can make an RMI call, .NET remoting, just a number of ways that they can communicate. And in order to perform this, you have to track all of them. So here's some examples of the transactional analysis in use. We've got the top functions. So here's all the methods that were called by this application, and how much time they took. On average, you see min, max, total, average. The most important one is total. Total time spent by a particular method. That means that method might, it's the thing that needs to be tuned if you're having performance problems, if it's caused by the application and not by the infrastructure. So it's called total exclusive time. If a method calls another method, you might spend 10 seconds calling the very top level method in your application, but if it takes almost no time and calls another method, then that time isn't exclusive to that method. So you need to track the exclusive time. That's the most important one. Here's the call tree. So if you look at, this is just from a fairly simple application. You look at the calls that it makes, and you can make a tree out of them, and how much time was it spent. So it's really detailed information about how your program is running. And then the other thing that's really informative is what SQL statements were called from the application and how much time did they take. And I know you can't read it, so I just I think they're going to be available online. You'll see a better example. So this is another summary of that. So this is over time, and we showed this in the metrics presentation too. Over time, where is the time spent on each of these components? It's spent in, and in this case we have 4 different types of breakdown. So if we break it down by tier, then we see that the cluster, that's the app server name, is spending most of the time. If we break it down by component technology, we can see that it's spending most of its time in servlet. By server, that's evenly balanced, and by application, the physician application is taking much more time than the MedRec application. And then you can pick any one of these and view the breakdown. That's the profiling. That's transaction profiling. Where is the time spent? So detailed, method level details, or in summary, because either one of those could show you the problem. That is really important. This is another kind of the same thing, but aggregated to the runtime architecture. So we overlay the time spent against the runtime architecture in one view. And then here, this is an example. That was all based on the bytecode instrumentation. SQL has transactions too, so we'll profile the I should zoom in. I should put more zoom in FX. You know, where's the SQL time spent? And this dashboard shows you it's spent in lock wait. So we're waiting for a lock. It's a logical resource, right? So you can profile the SQL server, and it's got its own language. It's not methods, it's types of waiting time. So instead of, when you call a SQL, you want to know what method it took, but the only detail you don't have a full call tree or something like that. You have, was it spending its time scanning? Was it spending its time using CPU? Was it spending its time waiting for a lock? So the next step is that you do, after you found out that, hey, my problem's on the database, it's this SQL, and it's caused by lock. Now what do? You need to do a deep dive. So you need to go look at that component in detail. And this is where I think the stuff you're doing in the labs will be the most relevant, is looking at a specific component in your infrastructure, like a database or a particular web server or a specific piece of middleware, and look at all the metrics and details that you can find about it. So application servers, databases, web traffic, all the things there. Any component, the reason you've been monitoring more than just the very basic is so that when you get to the deep dive, you can see all the details and figure out the problem. That's why you would have the resource consumption metrics in general, so that you can understand if resource usage is causing your problems. And you have to have context, so you can't just go look at that object. You want to look at that object based on what it's doing for your application. So if I'm looking at the ESX server, I want to see the usage from the application I was in first. So some examples. So this is an example of database. I was talking about the different wait states. So in this case, the lock wait spiked up, and we track the metric we have showing at the top is lock wait over time. So that is a pretty detailed example that a database administrator would know what to do with. They might clear the lock, and because there was some logical error. This is a virtual environment. We talked about dashboards. This shows you what's the memory utilization of the system, what's the what are all the I/O throughput? How is all that working? This is a fairly detailed view of the overall health of a hypervisor. And this is a kind of deep dive analysis on memory leaks that we do. So we track the heap and we look for types of objects that don't die. And if their numbers are growing and they never go away, that means you're going to run out of memory, and it's because of a bug in your code. So in Java, I mean, we're very used to garbage collectors these days, but it's possible to orchestrate a memory leak in Java. But because of garbage collection, it's trickier to track, and it doesn't fail as fast. So we have this kind of analysis so you can track the different kinds of objects. So in this case, hash tables are leaking. We've got a lot of there's hash tables, and they're growing and growing and growing, and they're never going away. Any questions on that? So the last of the 5 phases, analytics. And this is where we're spending a lot of time in research right now in Foglight, and this is one of the areas we're most interested in. The Gartner definition doesn't tell us what it has to do. The limit of analytics is the limit of our imagination. We can invent a new system for automatically troubleshooting a performance problem. That would be considered analytics. We could do intelligent baselining. We can do automatically discovering different transaction types, automatic categorization, root cause analysis, alarm filtering. These are all areas we're actually working on right now. But anything could be analytics that is doing work for the user without their input. So any kind of configuration, automatic problem solving, automatic categorization of a problem, helpful routing, whose problem is it? There's just data mining could be, that's a type of analytics. There's taking the APM data that we have and automatically sorting through it because it is so large. If you have a very large website, you might run 10 million transactions a day. What do you do with that data? Are you going to look at it all? So we can summarize it into metrics. That only gets so much. So analytics looks at all the data. So just a few examples. So we have we have this system. This is the same system we looked at before. We've got the time spent at the top, the browser, the app server, and the database. And we've also got some alarms. We had thresholds set, our metrics got collected, and we figured out that there's some alarms. But based on this picture, which of the alarms is important and which isn't? All right, well, we'll leave it at that. We'll come back after the 10 minutes.